In this question we want to solve for m, given that those vectors 2, negative 4, 3 and m, 2, negative 6 are both perpendicular to negative 9, negative 21, negative 22. Well, it's really easy to find a vector that's perpendicular to both of these. We simply have to find the cross product of these two vectors. And since these two vectors are non-collinear, 2 times negative 2 is negative 4, but negative 6 times negative 2 is not 3. So these are clearly non-collinear. Since we have two non-collinear vectors, if we cross them, we'll get a vector perpendicular to both. Now, what's interesting to note, though, is every single vector perpendicular to both will be a scalar multiple of that cross product. So a good strategy will be to get the cross product of this and then realize that no matter what, the cross product of this has to be a scalar multiple of this in order for our question to have meaning and in order for us to get a valid answer. So we get the cross product. 2, negative 4, 3 crossed with m2, negative 6 has to be some scalar multiple, we'll call it k, of the vector given in the question. So 2, negative 4, 3 crossed with m2, negative 6 has to equal negative 9k, negative 21k, negative 22k. Looks to me like we've got two variables here. We've got k's and m's. Alright, so what we do first of all is take the cross product here. Negative 4, 3, 2, negative 4. 2, negative 6, m2. Negative 4 times negative 6 is 24. 3 times 2 is 6. 24 minus 6 is 18. And so 18 is going to be our x component. 3m minus negative 12 is 3m plus 12. That's going to be our y component. And 2 times 2 is 4. Minus negative 4m means 4 plus 4m. That's going to be our z component. Now we see that these have to match up. 18 has to equal negative 9k. That'll be pretty easy to solve. Then 3m plus 12 has to be negative 21k. Well, once we know the value for k here, that'll be pretty easy to solve for m. And then we need to hope that the value for m and the value for k that we get here and here make this a true statement. And if it does, we're good. So 24 minus 6 equals 18. 18 has to equal negative 9k. That means k is negative 2. So far, no problem. Look at our y components. 3m plus 12 equals negative 21k. We just established k is negative 2. So 3m plus 12 is negative 21 times negative 2, which is 42. 3m plus 12 is 42. Subtract 12 from each side. 3m is 30. M is 10. Okay, so far we're okay. There's nothing wrong with k being negative 2 and m being 10. We hope it works on the z component. If m is 10 and k is negative 2, does 4 plus 4m equal negative 22k? 4 plus 4m equals negative 22 times negative 2. 4 plus 4m is 44. 4m equals 40. M is 10. Holy cow, that's what we had up here. M equals 10. So therefore m equals 10. If we want to, we can go back and see that letting m equal 10 will give us a scalar multiple of negative 9, negative 21, negative 2. And we put a smile on our face and move on.